You guys have done a lot.
So you're just prepared.
Alright, so lesson 3 is all about trigonometric ratios. We're looking at sine, cosine, tangent, as well as the reciprocal ratios for those 3. Do you guys remember going back to grade 10? Sine, cosine, and tangent? Little SOHCAHTOA? Yeah? Okay, let's just review. So for sine, we're dealing with so. So what is the O and the H?
Opposite.
Good. So if we're looking at this reference angle, in terms of this reference angle, opposites directly across. Okay, hypotenuse will be your longest length, always opposite the 90. And adjacent is always between the reference angle and the 90. So you guys got it. So is opposite over hypotenuse. Okay, cosine, ka. We have adjacent over hypotenuse. And lastly, tangent, toa, opposite over adjacent. Okay, now you guys have written SOHCAHTOA out like this before, but I like to write it like this, so you see the ratio. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if you like that too, you can write it. But if you're good with the SOHCAHTOA, then you can leave it. I love saying that word. Or acronym, I guess. SOHCAHTOA. So these are considered all the primary trig ratios. We also have the reciprocal trig ratios. What does reciprocal mean? What does opposite mean?
Flip.
Good. So the numerator and denominator flip from where they were located to. So if they're denominator, it's now the numerator. It's basically taking 1 divided by what you had before. Before we get into the next little bit, I'm just going to describe this triangle in terms, if we put this on a set of axes. Okay, this length here, if our vertex is at the origin, this length would be on what axis? So we can label the adjacent as our x. Okay, now the opposite side, it's going vertically up and down, so we can label that as y. Okay, and the hypotenuse, let's just imagine we had a circle. Okay, going from the center of the circle to the outside of the circle, what do we call that?
R.
Radius, yeah. Or r. So we're going to label our sides as x, y, and r. So if I'm applying these lengths to sine, we have opposite over hypotenuse. Your opposite would be a y. Okay, and your hypotenuse would be an r, so we have y over r. Your cosine is adjacent over hypotenuse, so we'd have x over r. And your tangent is opposite over adjacent, so that is y over x. So the 3 other trig ratios are the reciprocal trig ratios, and they're the reciprocals of sine, cosine, and tangent. So as you can see, cosecant is the reciprocal of sine, because it's 1 over sine. Secant is the reciprocal of cosine, 1 over cosine. Okay, and cotangent is the reciprocal of tan, 1 over tan. Okay, the only one that really makes sense with its language, if we take a look here, tangent has a reciprocal of cotangent. The way I memorize the other ones is their opposite first letters. So the sine ratio, its reciprocal is cosecant. Starts with a C now. Okay, and then cosine, its reciprocal is secant. Starts with an S. So for cosine and sine, it's just the opposite first letter. Okay, and for tangent, the reciprocal is cotangent. So cosecant is 1 over sine. If sine was the ratio of opposite over hypotenuse, then we could just take the, I'll just write this up here again, so y over r. Okay, then the reciprocal of y over r would be r over y. So we now have hypotenuse over opposite. Okay, for the reciprocal trig ratio of cosine, we have a secant ratio. That's 1 over cosine. So 1 over x over r. Okay, which if we took the reciprocal of cosine, which is x over r, it would just be r over x. And lastly, the tangent reciprocal ratio is cotangent, which is 1 over tan, so 1 over our opposite over adjacent, which is y over x. So 1 over y over x would just be x over y. Okay, so you're just literally flipping the numerator and denominator. Okay, and this is all applied in the example below. This time they've actually given you this set of axes and a picture, but we pretty much already summarized it. Okay, so our x-axis, that's our adjacent. On our y-axis, that's our opposite, and this is our hypotenuse. So if we were to label opposite, hypotenuse, adjacent again, just quickly, if you want to copy it down, sine is opposite over hypotenuse. What's the reciprocal? R over y, or hypotenuse over opposite. Cosine, ka. What is it? Pardon? Adjacent over hypotenuse. What is your adjacent length? What do we call it in this triangle? X, perfect. And our hypotenuse is r, so the reciprocal is secant. The ratio will be r over x. And lastly, tangent, opposite over adjacent, we get y over x. The reciprocal would be x over y. Now they're giving you a little note, like some students will create a phrase to memorize this, but personally, rather than trying to memorize 7 yellow rabbits and what the heck that means, I would just draw a set of axes. You have your x, your y, your r, and you remember SOHCAHTOA. I think that's ingrained, so trying to introduce these weird little sayings at this point might be a little tricky, so feel free. Sorry, 7 yellow rabbits. Yeah, forget about that. Alright, so what we're getting into in this lesson, it's really important to note where sine, where cosine, and where tangent will be positive or negative in what quadrant. So we're just going to do a little exercise to figure that out. So in quadrant 1, if we look at sine in reference to this angle here, okay, sine is opposite over hypotenuse, y over r. The y is in the positive quadrant, so y is positive, and r, the radius, will always be a positive measurement. So positive divided by positive, we get positive. Okay, so sine is positive in quadrant 1. Cosine, let's check out that. Okay, you guys gotta help me with the ratios because we just did 3 exercises on it. Adjacent over hypotenuse. What letters? X over r. Is x positive? Yeah. And r will always be positive. So cosine is also positive in quadrant 1. And then lastly, tangent is your opposite over adjacent. Positive over positive. Tangent is positive. That means that all 3 trig ratios are positive in quadrant 1. Put a big A beside there. Okay, quadrant 2. If I were to put a point on a bar, okay, x, y, the point is moving into quadrant 2, which means the x value would be positive or negative? Negative. So we have negative x, and y is moving up, so we have positive y. So just change this point to negative xy. Now using reference angle theta, okay, sine still opposite over hypotenuse, we have y over r. And that will be positive over positive. giving us a positive sine ratio. Let's check out cosine. Adjacent over hypotenuse is negative x over r. So we have a negative over positive. Cosine is negative in quadrant 2. And lastly, tangent, opposite over adjacent, gives us positive over negative, and it's negative. So the only positive trig ratio in quadrant 2 is sine. Put a big S. Okay, if we were to continue this process, we would have different points in different quadrants. What would x and y be in quadrant 3? Negative. So we have negative x, negative y. Put little negatives in front of the point. So negative x, negative y. So for sine, we have opposite, negative y over hypotenuse, positive r. So negative over positive gives us negative. Cosine, adjacent over hypotenuse, negative x over r. Negative over positive gives us a negative. And lastly, tangent is opposite, so negative y over adjacent, negative x. Negative divided by negative gives us a positive. The only positive trig ratio in quadrant 3 will be tan. Okay, and last quadrant, we're going to have positive x and a negative y. So if we figure out the ratio for sine, it's going to be negative y over r, opposite over hypotenuse. That's a negative over a positive. Sine is negative in quadrant 4. Cosine, adjacent over hypotenuse, x over r. We get positive over positive, positive cosine ratio in quadrant 4. And lastly, tangent, we get opposite, negative y over adjacent, x. Negative over positive gives us a negative. So the only positive ratio here is cosine. Okay, so if you want, you can just highlight the positives, which might, as you study again, remind you why we put the big C, A, S, and T. Okay, it's the positive trig ratios for each quadrant. So what we've developed is a bit of a rule to help us memorize this. So rather than having to do this whole process every time, okay, we can just memorize the cast rule. And it starts in quadrant 4, C-A-S-T. All the, starting with C, quadrant 4, cosine is positive. Quadrant 1, all signs are positive. Quadrant 2, sine is positive. And quadrant 3, only tangent is positive. Okay, so if you can remember that, it's really going to help for the next type of questions we're going to look at. There's another little thing at the bottom. It says add sugar to coffee. So for those of you who like coffee, you can start in quadrant 1 and sugar, I guess, too. Add sugar to coffee. It's just a weird little memorization tool that someone likes to use. Personally, I will refer to the cast rule over and over again. You're going to see me draw the C-A-S-T over and over again. So, now that we've gone through the cast rule, we're going to put it to practice. We're going to figure out which of these trig ratios will be positive or negative. And as you can see, we're using degrees and radians. Okay, so for sine 280, first thing we have to do is draw the rotation angle and where it's going to terminate. So we're at 0, 90, 180, 270, 280, there we are. A terminates in quadrant 4. Now we're going to draw the cast rule. C, A, S, T. Is the sine ratio positive or negative in quadrant 4?
Negative.
Negative, you got it. Okay. Part B, tan, 7 pi over 6. So draw your set of axes. Okay, if I just remind you guys, we label it as 0, pi over 2, pi, 3 pi over 2, and 2 pi. 7 over 6, what is that? 1 point. Calculate quick. Okay, 1.16. So, first of all, we should already know because it's an improper fraction, it's going to be past the 180. It's going to be past pi. Okay, but how far does it go? Because it's so close to 6 over 6, I knew it was going to be here, but what if it was a little bit more than 1.5? Then it would be in quadrant 4. Okay, so let's just draw our rotation angle. It's going to terminate in quadrant 3. So now I'm going to draw my cast rule. CAST. Is tangent positive or negative in quadrant 3? Positive. Good. Okay, now cosine 10 pi over 3. Okay, 0, pi over 2, pi, 3 pi over 2, 2 pi. How many rotations do you think we have there? 3.
Like one round and
So
like
keep
kinda
in
like
mind,
a little bit.
one rotation is 2 pi.
And a half.
So if we have 10 over 3, okay, we could figure out what that is. Or what you could do is just remember what we did last class, and you could convert this to degrees. Okay, so if you're struggling with where it's lining up, you could convert it to degrees. So we have 1800 divided by 3, that gives me 600 degrees. Okay, so if I subtract a rotation, then I get 240 degrees. So this rotates one full time around. There's my 360 or 2 pi plus another 240 degrees. So it terminates in quadrant 3. CAST. Cosine is negative in quadrant 3. How are we doing with figuring out the angles and where it's terminating? Let's just see here. Okay, if I just look at 10 divided by 3, we're getting 3.3 repeated. So 2 pi is right here. If I go another pi, I'm at 3 pi, and then a little bit more. Okay? So if I went too far, I'd be at 3.5 pi right here. So 3.3 repeated will be between pi, or between 3 pi and 3.5 pies. So we had to rotate around once and then figure out where does 3.3 pies fall. Okay. If that's too confusing, just go back to degrees and rotate around. Okay, now we have cosecant. Now one thing the notes didn't tell us, and I'll tell you, is whatever the sign of the primary trig ratios are, the reciprocal ratios will be exactly the same. So for example, all trig ratios, the primary or reciprocal, will be positive in quadrant 1. Okay? Sine and its reciprocal cosecant will be positive in quadrant 2. Tan and cotangent, positive in quadrant 3. And cosine and secant will be positive in quadrant 4. Okay, so it's related to its primary trig ratio. Let's do this next one here. Starting at 0 degrees, and we're going negative, so we've got to go clockwise. We're at negative 90, negative 180, and we can stop at negative 225 degrees. So using our cast rule, CAST, cosecant is the reciprocal of sine. So is it positive or negative? Positive. Good. Okay, now we have cotangent, negative 13 over 6 pi. What would give me a full negative rotation?
12 pi over 6.
Good, 12 pi over 6, because 12 over 6 is 2, right? So let's just draw, draw our set of axes. We have 0 pi, half a pi, full pi, pi and a half, 2 pi. Okay, but we have a little bit more than 2 pi, so we've got to go a little bit further into quadrant 4. And if you have to, just label it 0 pi, half a pi, pi, pi and a half, 2 pi. Oh, we're just a little bit over 2. 13 over 6, what's the decimal on that? 2.16 repeated. So yeah, I think we're pretty accurate. Okay, now going ahead using the cast rule, we really only have to label here. We have a C. Okay, cotangent, its reciprocal is tangent. We can have positive or negative. Negative. Good job. Secant, 1,000. How many times are we going around? Almost 3 times, okay. So if you took away 2 rotations, what angle would you get? So 1,000 minus 2 rotations, you got 280, okay? So we're going around 360, 720 plus 280, terminating in quadrant 4. C-A-S-T. Secant is the reciprocal function of cosine. We're terminating in quadrant 4. Cosine's positive, so its reciprocal secant will also be positive. Alright, so using the cast rule, we can determine if the ratio will be positive or negative based on where it terminates. Okay, but we also have this handy device called our calculator, and that will help too. So you'll notice that in question 3, it's the exact same questions as we just did. But this time we're going to use our calculator to figure out the ratio. And that ratio will be positive or negative. Okay. One thing that's important is if we're dealing with radian measures, our calculator needs to be in radian mode. But if we're dealing with degrees, then our calculator needs to be in degree mode. Does everyone know where their mode button is?
Yeah.
Okay, our first question we're going to do is dealing with degrees. So if you guys can, press mode, go down to degrees, but you have to press enter on degrees. And just so you guys know, when you reset your calculators, you'll always put it back to radian. If you ever need to do trig and you need degree mode, you have to change it yourself. Alright, so let's just talk about this example first. So, most calculators have the ability to calculate the values of sine, cosine, and tangent in degrees and radians, okay, by changing your mode. But to calculate the values of the reciprocals, cosecant, secant, and cotangent, you need to use the reciprocal. Okay, so for example, if you want to calculate cosecant 5 pi over 6, first of all, make sure you're in radian mode. And then you would go 1 divided by sine 5 pi over 6. Okay, so if you're finding a reciprocal function ratio, you have to make sure you go 1 over the primary ratio. Okay, conversely, you could figure out what sine pi over 6 happens to be 1/2, and then you have to take the reciprocal of that, given your answers too. Okay, yeah.
You know, like second, like sine, it says like sine negative.
So second sine is when you're finding an angle.
Oh.
Okay, so do not use second sine.
Okay.
The symbol for that doesn't actually mean reciprocal. Okay. So I'm glad you asked that question. Just so you guys know, I'll just put a note, do not use second sine or reciprocals. Okay? So although it gives the power of -1, which implies reciprocal, it's not actually the function for that, okay? So don't use that. Let's just start easy, okay? We have sine 280 degrees. What mode am I going to be in? Degree. Okay, all you're literally plugging in is sine 280, and can you guys help me with the trig ratio to 4 decimal places? Negative.
0.9848.
Okay, negative 0.9848. If you were to compare this answer to what we did above, was sine 280 negative using the cast rule? Yes. Okay, so this is a little shortcut if you're feeling a little lazy, I suppose. You do need to know the cast rule, but if you want to figure out if that's positive or negative, you can just put it in your calculator. Okay, because we're in degree mode, let's just do all the ones with degrees first. What's the next question that has a degree?
Oh,
Okay, E, negative 225, perfect, degrees. Okay, cosecant is the reciprocal to sine, so we would calculate 1 over sine negative 225 degrees. And to 4 decimal places, what do we get there?
negative 1.4142.
Okay, 1.4142. Josie, do you have a question? You sure?
Yeah.
Okay.
Wait, are you doing degrees or radians?
Degrees.
But like when you solve the first one, that's for radians.
So the answer is just the ratio. You remember we looked at the triangle? Actually, I'll go to 280 degrees.
That's cosine.
Okay, so if we take a look at the sign here, this would be negative y over r. So it's taking the value of y and r, and it's just dividing the two. And it would give you this ratio. Okay, so this isn't a radian answer, it's just the ratio of 280 degrees right here. Okay, the rotation angle to that terminal arm.
But isn't it different? Like if I had my calculator on degrees, I'd get a different answer.
You should be in degree mode. When you have degrees, you use degree mode.
So whenever there's pi, you have to switch back.
Exactly. For these ones, we would need to use radian mode. So that's why I'm just being a little lazy. I wanted to do all the ones in degrees first. That way I don't have to change my mode every time. Okay, so sine 280, we got a ratio. Cosecant, negative 225 degrees, we got a ratio. Okay, do we see any other questions that have degrees? Okay, G, secant 1000. So that would be 1 over cosine 1000 degrees. Okay, what do we get there? Already answered them, so I might as well verify with you guys.
5.7588.
Yep. So 5.7588. Good job. Okay. Now, are there any other ones that have degree?
Sine
9 90? Do you guys see a little degree symbol?
Nope. No.
No. So don't make the mistake. This is not degrees.
You're wrong, Chris.
I was wrong. Sorry, too. Me too.
I know, I think
So because there's no degree symbol, this is a radian measure, which means we have to be in radian mode. So since we're talking about it, let's calculate this one. First, we got to change our calculator to mode radian, okay, and then we're going to go sine 90. You should get 0.8940. Okay, let's go back to B. Tan, 7 pi over 6. You're in radian mode. You're literally putting in the pi into that. So tan 7 pi divided by 6. To 4 decimal places.
0.5774.
You got it. Okay. Are you guys getting the hang of this?
Yeah.
Okay. I think you probably know how to put things in your calculator, so we won't spend too much time on this. But of the ones that we did we have the same sign, positive or negative, in comparison to what we did above? Yes. We did. So moving on. We're basically going to figure out equivalent trigonometric functions using acute angles. Pardon? Yeah, of course. Are you feeling okay?
Yeah, I just have a really bad headache.
Make sure you drink lots of water. So trig ratios for any angle are either the trig ratios of the reference angle or they're the negative of the trig ratios of the reference angle. So to figure out the same trigonometric function using the acute angle, first what we need to do is use the cast rule, figure out is the ratio positive or negative. Okay, so using the cast rule, we can figure out is that measure and the trig ratio going to be positive or negative. Then we're going to figure out the reference angle. Who remembers where the reference angle always will be located?
Between the x-axis.
Good. Between the x-axis and what? Terminal arm. Perfect. Okay, so that's our reference angle. And then we're going to combine the two. So let's just get right into the example. We have cosine 7 pi over 4. So first thing, we've got to figure out where does that angle terminate. Okay, if you don't like radians, then you can convert this to degrees. Let's practice. 7 pi over 4 to degrees, we'd have to multiply by 180 degrees over pi. What do you get? We're just going to practice.
What mode is this?
350.
Doesn't matter the mode right now. We're just calculating the degrees. So 315 degrees, you got it? So that is, suppose 315 degrees. Okay, so that's a little bit easier sometimes to figure out what quadrant it's going to fall in. And we can terminate in quadrant 4. So using degrees or using radians, you can now figure out your reference angle, which is the angle that falls between your x-axis and your terminal arm. So we need to figure out this angle here. Because we started in radians, I'm just going to continue to use radians. We need to go 2 pi minus the rotation angle, which is 7 pi over 4. So if we calculate that, getting a common denominator, 4 times 2 is 8. 8 minus 7 is 1 over our common denominator, 4. So this is your reference angle. And all I did here was I just multiplied, I needed a common denominator of 4. So if I multiply 4 in the denominator, I also need 2 in the numerator. So 4 times 2 is 8. 8 minus 7 is 1 pi. Okay? So, oh, sorry.
Well, like when I punched that in my calculator, like the cos 7 pi over 4 times 180,
Yeah.
I got 40.5.
Sorry, say that again, what you calculated? Cos 7 pi over 4?
Like, did you not put the cos in when you multiplied it? Or,
Yeah, all I'm doing right now is finding the reference angle in radians.
so you just went 7 pi over 4 times 180 over 4?
This here,
Yeah.
this was just to put it into degrees if you like using degrees better.
Okay, but when you punched it in, you didn't put cos.
I didn't use cos at all. No,
Okay.
I just converted the radian to degrees.
Okay.
Okay, and So if we were talking about degrees, the reference angle, if we went 315, the reference angle would be 360 minus 315, so we'd have 45 degrees. But in radians, a full rotation is 2 pi, so we go 2 pi minus the rotation angle, which was 7 pi over 4, and that leaves us with pi over 4, which is equivalent to 45 degrees. So that's our reference angle. Now what we have to do is use the cast rule and decide, is cosine positive or negative in quadrant 4? Okay, it terminates in quadrant 4, cosine is positive. So the equivalent trig ratio for cosine 7 pi over 4 would be positive cosine pi over 4. And if you're unsure if you got it right, all you have to do is plug this in. So what is cosine 7 pi over 4 as a decimal? What mode are you in?
Radian.
Radian, good. What's your decimal?
0.7071.
0.7.
071.
Okay, and if you put in cosine pi over 4, what do you get?
System.
0.7071. Okay. So to check, you should have that this decimal is equal to that decimal. Hannah, did you have a question?
No, I'm good now.
What was your question?
No, I was just asking what did we just find?
So basically, we found the same trig function. We found an equivalent trig ratio, basically.
So it's not like the degree or anything. Is it like we were using? Never mind, that's confusing. I don't know what I'm saying. It's okay.
Maybe I tried talking about degrees too early. Just some students, they really struggle with figuring out where the rotation, like where the terminal arm ends. Okay, so I decided, well, instead of thinking about 7 pi over 4, let's put that to degrees, and then we know where it terminates. Okay, radians are very new for you guys, so sometimes it's tricky to figure out where it goes. Okay, let's look at cotangent negative 100 degrees. Okay, negative direction, we're going clockwise, so we're at 0, negative 90, there we go, negative 100. So before we find the reference angle, let's use our cast rule first this time, showing you that the steps are interchangeable. Okay, cotangent, will it be positive or negative in quadrant 3? Positive. So cotangent negative 100 degrees will be equivalent to positive cotangent, and we need to figure out what our reference angle is. Okay, so what's this angle here? The difference between negative 180 and negative 100 will be 80 degrees. Okay, and just note, reference angles always have to be positive. So, if you were to put in your calculator cotangent negative 100, in other words 1 over tan negative 100, and then you set that equal, or you figured out that decimal, will it equal 1 over tangent 80? Okay, 1 divided by tan 80. .1763. Okay, and 1 divided by tan negative 100 gives me the same decimal, 0.1763. Okay, so as long as left-hand side equals right-hand side, you know that you did it correct. This is the equivalent trig function. And the only difference is we're using the acute angle. Okay, lastly, sine 11 pi over 2, and maybe this time I won't change to degrees, I'm just going to use radian measures just to see how we do. So 11 over 2. Okay, let's just think about what would be a full rotation. 4 over 2. Okay, that's the equivalent to 2 pi. Okay, 8 over 2 pi would be 2 rotations. Do we get 3 rotations? No, we're close though. Okay, so let's just draw this out. We have 2 pi, 4 pi, oh, 6 pi. Did I do this right?
It's,
It'd be less.
like, it's gonna be like, it's gonna be
Below.
one like quarter less right there.
Oh.
Let me start again. Okay, so
One,
2 pi,
yeah. 4 pi.
4 pi, which would be 8 pi over
Yeah.
2, and then, yeah, we're
And-
not quite at 12 pi over 2.
So, does that mean we're on like the, so, 3 pi over 2, so we're on like the little straight line down, like that one?
I meant to write this as 6 pi. I was thinking 3 rotations, I wrote 3. It's equal to 6 pi, which is 3 rotations, okay? So we terminate in quadrant 4. What's this? Okay, so if we're terminating in quadrant 4, we'll write down our cast rule. Is sign positive or negative? Negative. Is it okay if I erase this?
Yeah.
Okay. So sine 11 pi over 2 is a negative ratio. And now we have to figure out what will be the reference angle between 3 full rotations and our rotation angle. So 3 full rotations, that's 12 pi over 2. We're going to subtract 11 pi over 2. Okay, so from there we get, this isn't making sense.
I think we're right on like the line, like right on like between the, it's between the there.
It's supposed to just
right
go
there,
here?
Yeah, right there.
Yeah, I've gone too far. Okay, even I get mixed up with pi sometimes. So when we convert this to degrees, what do we get? 11 pi over 2.
990.
990, okay. So if we subtracted
From 7.
2 rotations of 360 degrees, we would get 270 degrees. Okay, that makes more sense. I'll go back to this in 1 second. Okay, so we rotated once, twice, and 270 degrees more, so we're actually terminating right on the axis. Okay, and still sign will be negative in between those 2 axes. Okay, so we have a negative ratio. Now we need to figure out the reference angle. So just by looking at it, from here to here, what's that angle? 90 degrees. Or if we went backwards to the x-axis, it's still 90 degrees. So 90 degrees as a radian. You guys remember when we labeled 0, pi over 2, pi. Okay, so it's going to be negative sine pi over 2. And I'm just going to allude back to my calculation before. 3 full rotations would have been 12 pi over 2, or 6 pi. If we're subtracting 11 pi over 2, we result with just pi over 2. Okay? And if we were to calculate the decimal of negative sine pi over 2, you would find that you get the exact same decimal as sine 11 pi over 2. So if you're like me and you're struggling to figure out where it terminates, just put it to degrees, and eventually you will get better with the pi, hopefully. But for me, I work better in degrees. That's just, my head works better figuring out where it terminates. Okay, so if you prefer that as well, just convert it and then figure out how many rotations you would need to go around and what's left over. Okay, that's what I like to do anyways. If you're good with pi, then go for it. So moving on, we're going to go back, rewind to grade 10 again. You guys remember Pythagorean theorem?
Yeah.
Okay, so using the smaller lengths of a triangle to figure out the hypotenuse length. We have x squared plus y squared equals r squared. Okay, in this case, we're given a point that's lying on the terminal arm, negative 15, 8. what I'd like you guys to do is draw a triangle. And then we're going to talk about the x and the y coordinate of that point. The x coordinate is negative 15. So for this triangle, this length is negative 15. The y coordinate is positive 8, which means we're rising 8. So we now have our adjacent and we have our opposite length. Okay, if this is your reference angle, okay, opposite adjacent, r is our hypotenuse. We're going to solve for r. So if we have a right angle triangle, and if you drew that straight, it would be right angle. Okay, we could calculate r by using Pythagorean theorem. So x squared plus y squared equals r squared. Now plugging in, we get negative 15 squared plus 8 squared equals r squared. And what's negative 15 squared plus 8 squared? Is it 289?
Yeah.
Okay, and then to get r on its own, we just square root both sides. And r equals 17. For part C, we're now using the side lengths x, y, and r, and we're going to write our primary trig ratios and our reciprocal trig ratios. So you guys remember the beginning of the lesson, sine theta equaled opposite over hypotenuse. Okay, our opposite in this case is 8, and our hypotenuse we just calculated to be 17. If it helps, just put r equals 17 on the diagram. Who remembers the reciprocal trig ratio for sine? Cosecant, very good. So CSC theta will be equal to the reciprocal of that, 17 over 8. Okay, now let's do cosine. Cosine was adjacent over our hypotenuse. Our adjacent's negative 15 and our hypotenuse is 17. So we have negative 15 over 17 as our cosine ratio. Okay, the reciprocal is secant. So taking negative 15 over 17 and applying the reciprocal, we get 17 over negative 15. And lastly, we have tan. Tan is opposite over adjacent, so y over x. Our y is 8 and our x is negative 15. The reciprocal would be cotangent, x over y, so we get negative 15 over x. Yeah, but sometimes we won't be given a point, we'll be given a trig ratio. So moving on to example number 6. So we still need to find some trig ratios, but this time our hint's a little bit different. We're not given a point. They're telling us that cotangent A is equal to the square root of 5 over 2, and that sine A will be negative. Okay, now if you look at this, positive or negative? Positive, okay. So we have C, A, S, T. Where is tangent positive? 1 and 3. Okay, but then sine A is negative. So is it going to be in quadrant 1? No. So pretty much we're going to be in quadrant 3. Okay, based on those two hints that we're starting with. So for part A, since the cotangent ratio is positive and the sine ratio is negative, the angle A must terminate in quadrant 3. So let's just draw quadrant 3. We're going to draw a triangle. Okay, if we were to think about tangent, that would be opposite over adjacent, but cotangent will be adjacent over opposite. So the root 5 is actually our adjacent, and the 2 is our opposite. So in reference to angle A, our opposite was 2 on the y-axis, and we have square root 5 on the x-axis. But because we are in quadrant 3, the value of x will be negative. Okay, and the value of y is going down, so it's negative. Therefore, we have the point negative root 5, negative 2. For part C, we're going to calculate what is r. So we have to use Pythagorean theorem. And the goal of that is to eventually solve for the trig ratios for cosecant and secant A. Okay, so x squared plus y squared will equal r squared. My x is negative root 5 squared. My y is negative 2 squared. Let's calculate this. So I get positive 5 plus 4 is 9. The square root of 9 is 3. So my radius is equal to 3. And if you want, you can label that on your picture. So cosecant is a reciprocal of sine. Sine is always opposite over hypotenuse, so the cosecant or reciprocal will be hypotenuse over opposite. In this case, our r is 3 and our y is negative 2. So this is your trig ratio for cosecant. Negative 3 over 2. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so secant will be hypotenuse over adjacent. The hypotenuse is 3, the adjacent is negative root 5. Now one thing to note is you're never allowed to have a radical in the denominator, so we need to rationalize. And rationalizing means you multiply by the square roots to eliminate the radical in the denominator. Okay, so I'm multiplying the numerator and denominator by root 5. And the result is 3 root 5 over negative 5. Or you could have negative 3 root 5 over 5. Doesn't really matter. As long as the negative is out front somewhere.